Have you ever wondered why astronauts float in space or why your weight changes when you travel to different planets? The answer lies in understanding the difference between mass and weight. It's a fascinating topic that touches on the very fabric of physics in our everyday lives. To start, let's clarify what mass and weight actually mean. Mass is a measure of the amount of matter in an object, usually expressed in kilograms or grams. It's a scalar quantity, meaning it has magnitude but no direction. On the other hand, weight is the force exerted on that mass due to gravity. It's measured in newtons or pounds and is a vector quantity, which means it has both magnitude and direction. Now, let's dive a little deeper into this concept. First, one of the most interesting points to consider is that mass remains constant regardless of location. Whether you're on Earth, the Moon, or floating in space, your mass remains the same. For example, if you weigh 70 kilograms on Earth, you will still weigh 70 kilograms in a spaceship. However, your weight will change depending on the gravitational pull of the celestial body you are on. Secondly, let's talk about gravity. The weight of an object is directly proportional to the strength of the gravitational field acting on it. On Earth, we experience a gravitational acceleration of approximately 9.81 meters per second squared. But on the Moon, this acceleration is only about 1.62 meters per second squared. This means that if you weigh 60 kilograms on Earth, you would weigh only about 10 kilograms on the Moon. Another intriguing point is how this distinction affects our daily lives. When we step on a scale, we are actually measuring our weight, not our mass. This is why people often confuse the two terms. In scientific contexts, however, it's crucial to use them correctly to avoid misunderstandings, especially in fields like engineering or physics. Lastly, let's touch on the concept of weightlessness. In space, astronauts experience what's called microgravity, which gives the sensation of weightlessness. However, they still have mass. It's just that the gravitational forces acting on them are much weaker than on Earth. This is why they can float around in their spacecraft. In summary, while mass and weight are often used interchangeably in everyday conversation, they are fundamentally different concepts. Mass is the amount of matter in an object and remains constant, while weight is the force of gravity acting on that mass and can vary based on location. Understanding this difference not only enriches our knowledge of physics, but also enhances our appreciation for the universe we live in.